Hey guys, good evening. I was just browsing the web, came across this particular video on YouTube where this guy with YouTube channel name Stuck at Prototype builds a physical focus bar, which is an excellent video by the way. I was just going through the bill of materials to build something similar for myself. Then I noticed that uh, the component cost might increase a lot if I start building it. Right? ESPH2 Mini 1. This itself in India might cost uh, around 300 to 400 rupees, roughly 363.65 dollars. That is around 350 rupees. Uh, LEDs will cost another 50 cents or around 50 rupees. Buttons another 50 cents or 50 rupees. Indian buzzer, 10 cents. The overall cost for this might go beyond 1000 rupees, right? So I was just thinking, can we get this build done within 500 to 600 rupees, right? Or $5 to $6, or even lesser than that if we are willing to put in our work towards making our own PCBs, right? Then I started exploring things. So here is my quick design where we can make sure that the bill stays lesser than 500 rupees. So what I have done is instead of using ESP32 as the brains of it, I've used CH552G, which is a enhanced 8051 microcontroller, right? Uh, Costs somewhere around 10 cents to 20 cents, or in Indian rupees around 60 rupees per chip, right? Uh, Again, some switches, right? I have chosen around six switches. I'll let you know why six switches as well, because to set timing at various durations. This particular microcontroller doesn't require LDO because it has internal LDO. Uh, I have been taking directly instead of USB-C, I'll be using micro USB so that it becomes easier. Uh, we have some decoupling capacitors for 3 volts and 5 volts respectively, 10 microfarad and zero point 0.1 microfarad capacitors for 3.3 volts and 5 volts. Programming touchpads or shorting them so that we can program it via USB. I'm using the same USB to deliver power, right? The USB bus gives 5 volts. I'm not going in depth on any of the power regulators as such, like ESD protection or Zener diodes for regulating power, because that would be overkill. And anyhow, this would be on a desk. Probably we might be supplying it using a power bank or a wall adapter. They are pretty good enough. Uh, Here I have around six WS2812B LEDs where I'll feed in one line of the LED, and the data in and data out goes as it is, right? So each WS2812B requires zero point 0.1 microfarad decoupling capacitor so that the power stabilizes over its power rail, right? A simple diagram, I have not yet built this, but I thought, okay, this will work because I have built various other circuits using CH552G, and they seem to work pretty good, right? With respect to the timer, here is the uh, entire PCB layout. The PCB, as you see, I have put it in millimeters. This the PCB stretches from 100 millimeter to 20 millimeter, a small form factor per se, right? which is good enough to put on a desk, right? Uh, so here, if you see here, this is the micro USB where it feeds the 5 volts to the decoupling capacitors. This would be our main line for power. Uh, then we have our data lines. The thing with CH552G is you need to pass 3.3 volts to the data line plus D plus through a 10K resistor for limiting the current so that the chip comes to boot mode so that we can program it using USB, right? When it is not high on the data plus line on 3.3 volts, it would be working normally. So pin 9 of this particular chip, I have put it on as the data pin for the LEDs. The LEDs draw power directly from the USB again, right? So that they have enough power. The USB is USB, micro USB, when powered through a wall socket or your system or a power bank delivers somewhere between 4.5 volts to 5 volts, which is good enough for the RGB LEDs. I have taken 6 switches. The thought process right now is the first switch will configure it to 5 minutes, 10 minutes, 15 minutes, 30 minutes, 45 minutes, and 60 minutes as uh, I have seen it in that particular Pomodoro timer review or the Pomodoro timer built by Stuck at Prototype, right? So if I have to put a cost analysis on this, before I get into the cost analysis, let me show you how this looks. This is a pretty decent board. Here we have our micro USB section, which sits uh, on the right hand side of the board, followed by our microcontroller board, decoupling capacitors, the data pin resistor, and a decoupling capacitor for the 3.3 volts rail as well, right? We have 6 input buttons configured at 5 minutes, 10 minutes, 15 minutes, 30 minutes, 45 minutes, and 60 minutes. My current thought process is I can select any one of this and the timer should run till that particular minute, right? We have instead of 10, I have just put in 6 so that even if if the data is set at 60 minutes, each LED takes on for 10 minutes, right? From dim to max, dim to max, dim to max on each LED. If it is 15 minutes, we can run through it. So it is all configurable via software, so that should be good to go. So here is a quick setup. So I have not done the cost analysis on this. Let's do the cost analysis quickly by taking the bill of materials for this. Let me take the bill of materials directly here. Export. Okay, it got exported. I can go to that particular folder. Uh, I have it here. Let me open that. So, so 0.1 microfarad capacitor at 0603. Again, as a design constraint, I have kept it at 0603 or 0805 so that it becomes easier for us to manually hand solder it, right? I'm keeping it as DIY or hobby friendly so that it becomes easier. So let me do the cost analysis in both uh, INR and USD. So in INR, it might cost me around 1 rupee each. Uh, Again, this would probably be around 3 rupees because it is 0508. LEDs around 5 rupees each. Resistor around 0.20 cents, 20 0.2 rupees. switches around 5 rupees each. These are already built in, so this doesn't cost anything. Uh, Around 60 rupees and USB around 5 rupees, right? So if I multiply this is equal to this into this and take the cost analysis, the bare uh, cost of the components is around 136 rupees, or even if we round it off to 150. And let's consider the cost of making the PCB board to be around 200 rupees per board, and miss items such as uh, solder paste and other things, solder gun, another 50 rupees, and uh, as a reward we pay ourselves around 100 rupees. Mm, I would do it for free for myself, but labor, let's say this costs around 2 hours, and I pay myself around 100 rupees each time. So that would cost around 200 rupees. This is so the cost would be around 400 within 500 range per board. But if we go ourselves and pay, it will go up to 600. So that's with respect to our cost analysis on this board, which is good enough instead of spending various uh, or even high uh, cost for components. If we can make good with low cost components, that's more than sufficient for a desktop application, right? That thought just came because the cost of a single ESP32C3 goes more than 300 sometimes in India. So thought we can get done with that within a cheap 500 to 600 range. So that's with respect to uh, my thought on this particular project. If you guys want to look at this particular project, you guys can go to my uh, GitHub page at Vedaprakash ms slash Pomodoro timer, and you'll find all the required aspects for it, right? Uh, so feel free to utilize the page, my repository, and if you guys want to program it, it is as required, right? So I have put in Pomodoro timer version 2, uh, so which is a good place to start for you guys. Thank you.